Now, sometimes that drawing the triangle method doesn't actually work real well. And let me show you an example. We want to find the sine, cosine, and tangent of 0. Okay. So we want to find a pencil first. Let's get that going. We will find the cosine of 0. Oh, not theta, sorry. The sine of 0 and the tangent of 0. Now, the problem is at 0 degrees, we can't really draw a triangle there, okay? So what I want you to do is just pretend that we can. I'm going to just put a point there. We'll just make it a really simple point. It is going to be the point 1, 0. Okay. Now, go back up to the top, that very first box at the top of the page. Remember, we said that cosine is x over r. It's the adjacent over the hypotenuse. So our x value in this case is 1, and our radius is 1, which means our cosine is 1. Sine is y over r. So our y value at that point is 0, and our radius is 1. So sine of 0 is 0. And then tangent is y over x. So we have 0 over 1, which is 0. And you can verify these, plug them into your calculator, check and see that they work. Okay, so now let's go to pi over 2. We want to find the cosine of pi over 2, the sine of pi over 2, and the tangent of pi over 2. Okay, again, pi over 2 is way up here, so it's really hard to draw a triangle, so we'll just pick a real simple point there. We'll do 0, 1. So remember, cosine is x over r. Our x-coordinate is 0, and our radius is 1. So the cosine of pi over 2 is 0. Sine of pi over 2 is y over r. Our y value is 1. Our radius is 1. So the sine of pi over 2 is 1. And then tangent of pi over 2 is y over x. So our y value is 1. Our x value is 0. We cannot divide by 0, so this is undefined. There's no solution. I want you to check out the notes. I did the sine, cosine, and tangent of pi and 3 pi over 2. So this is only half the problem, but I think you can figure it out from here. The last thing that we want to talk about is something called a reference angle, and we're going to use this quite a bit. A reference angle is an acute angle formed with the x-axis, okay? So it's between the terminal side and the x-axis. So if you were in the first quadrant, okay, right here, your reference angle is this, okay? It's the acute angle made with the x-axis. If your angle is here in the second quadrant, okay, this is your angle theta, but your reference angle is over here, okay? It's the acute angle made with the x-axis. It's not this one because that one's not acute, okay? If you're in the third quadrant, okay, so your angle is all the way over here. Obviously, that's not an acute angle, so your reference angle is here, not this part. And if you're in the fourth quadrant, okay, so your angle comes all the way over here. Clearly, that's not acute, so this is your reference angle. Now, we need to be able to find all of those reference angles, okay? And I think you'll be able to do this. There are formulas down here at the bottom, but sometimes it's easier just to do them just by doing them. Okay, so let's take a look at 213 degrees. The first thing we need to do is draw 213 degrees. So that's more than 180 and a little bit more. So there's 213 degrees. The reference angle is going to be this angle. Now, to get this far, that's 180. We want to know this little piece that's left, so we're going to take 213 minus 180. And that gives us a reference angle of 33 degrees. All right, let's check out the next one. We have 14 pi over 9. So 14 pi, that's definitely more than 1. Let's see, that's more than a half. So this is in the fourth quadrant. Okay, there's our angle, 14 pi over 9. Here's our reference angle. Okay, so we need to figure that out. Now, remember that all the way around the circle is 2 pi, and we're going to subtract that 14 pi over 9. And when we do that, we get common denominators and all that good stuff. We're going to get 4 pi over 9. All right, let's take a look at 4 pi over 5. 4 pi over 5, that's just a little bit less than 1, so that angle is going to be over here in the second quadrant. The reference angle is going to be right here. Okay, so if we came all the way over, that would be pi. So we're going to take pi minus 4 pi over 5, and our reference angle is going to be pi over 5. And then our last one, this one is in radians. Notice there's not a little degree symbol, so it's 11.6 radians. Remember, it's 6.28 all the way around the circle. I don't know, how much do we have left then? 11.6 minus 6.28 is 5.32. Okay, so this is actually coterminal with a 5.32, so that's going to be over here. And this reference angle is going to be right here. So to find that reference angle, we're going to take 2 pi, which is 6.28, minus that 5.32, and our reference angle is 0.96 radians. So that is it for lesson 6.3a. If you are not sure about these reference angle ones, because like I said, we are going to be using it a lot and it's pretty important, just go to YouTube and Google like reference angle videos, and you may be able to find some other ones to just give you some more examples to check out.